Hello everyone, welcome back to MAC1140. So last time in section 4.3 we learned a bunch of different theorems, and the purpose of those theorems is to find a possible zero of a polynomial function. And what is zero? Zero is nothing but the intersection point between the graph and the x-axis, right? And zero has also have another name. It's called solution of polynomial function, a polynomial equation. Well, what's the difference between polynomial function and polynomial equation? The difference is that, you remember, every time we want to write a function, we always start with fx equals something. And now, if you set fx equals 0, then that something equals 0, then the whole thing will become polynomial equation. Okay, and finding zero or finding solution is kind of the same thing. Okay, I mean, the solution is nothing but also is the intersection point between the graph of polynomial and the x-axis. Okay, and today we're gonna learn how to solve a polynomial equation, and we're gonna learn how to solve polynomial inequality. For polynomial equation, there are several methods, so let's go through one by one. Okay, so let's start with the topic today, section 4.4. Polynomial equation and inequality. Okay. So first one, solving polynomial equation. Okay. There are several methods of solving polynomial equation. First method, we can use the traditional factoring method. And we apply the zero product property. Okay, this method is you can use you can solve many polynomial equations with this method. The second method is well, I think I'm gonna go through the second method later. Let's start with the factoring method. I know everybody know what zero product property is, right? Zero product property states that if a times b equals 0, then a equals 0 or b equals 0. So our goal is to factor polynomial into factoring form so that we can set each of them equal 0. All right, example. Let's start with our first example, and this example is very easy. For example, we have x to the third plus x squared plus x equals 0. Okay, this is a polynomial equation. Okay, which polynomial equation is the third degree polynomial. So you see that with the factoring method, we try to find GCF. That's our priority. So you see all three terms over here. GCF must be x, right? So I have to factor x out. So I have x squared plus x plus 1 equals 0. Okay, then you see this in the product form already. But the thing, this is quadratic, and you have to see that if this quadratic can be factored or not. X squared plus x plus 1, you cannot factor. You cannot factor. The only way you can solve for the x for this quadratic is to do a quadratic formula. Okay, so I'm going to just apply zero product property for two over here. The first one is x equal to 0, or x squared plus x plus 1 equals 0. Okay. Alright, is x equal to 0 is one of the solution of this polynomial equation. This one we have to use quadratic formula. You know, you're not allowed to forget quadratic formula. So quadratic formula is everybody know that. So it will be what? It should be x equal negative b, negative 1 plus minus square root of b squared, 1 square minus 4ac over 2a, so 2 times 1, so it will be negative 1 plus minus square root of 1 square minus 4 over 2, right? 1 square minus 1, 1 minus the square root of minus 3 plus minus square root of negative 3 over 2. And we keep going because we already learned imaginary number. Remember, imaginary number is, so it could be the solution of a polynomial. So with minus 1 plus minus I square root of 3 over 2. So totally how many solutions we have? So we have first 1 and plus minus, so we have 2 more, so totally we have 3. You know, it satisfies the fundamental theorem of algebra by Gauss. Remember, because the highest exponent over here tell you the number of zero equation. Okay, even though over here we have only one real and over here we have 2 unreal ones, but that's okay, it's still counted. All right, so that's the first example. Second example. Alright. Second example, x to the 4 plus x cubed plus x squared plus x equals 0. Okay. So I have a 4 degree over here. It means that possible we will have at most 4 different 0. It might be repeated. Alright, and again we try to use factorial method, where I think I'm going to factor by grouping, because I'm the first to group. I group the first 2 terms, so x to the third, so x plus 1 over here, and over here I group x, so x plus 1 over here, and I factor one more time, so x plus 1 raised to oh, I think I missed something, right? No, we're good. So I have x cubed plus x, right, equals 0, right? And I factor one more time, so I factor because x to the third and x, they have x in common, so you have take x out, so x squared plus 1 equals 0. Now everything in product form. Everything in product form, I think you can factor. I think you can using a zero product property now. So I have x equal to 0, or x plus 1 equals 0, or x squared plus 1 equals 0. So you have one real solution, 2 real solution, and this one is imaginary solution. Okay, so it could be I plus minus I. So totally how many? We have 1, 2, 3, 4. So you see that satisfy fundamental theorem of algebra. Okay, 1, 2 real and 2 unreal. Okay, let's see what else. I mean, if it is in factor form already, it's going to be very easy. You know, if it is in factor form already, then you just need to split them up. You know, then there's nothing you have to do. Okay, for example, I have example 3 right here. If it in factor form, for example, x plus 1 square, x it's 2x minus 1. I'm sorry, it's 2x minus 1 times x plus 3 square times x minus 1 to the third power equal to 0. This is polynomial in factoring form, and even in factoring form, you see that we can solve it easily. Okay, you just set each of them equal to 0, but if it's not, then you have to factor. Okay. Okay. Let's see. What if I have something? What if I have something like this? Example 4. I have x plus 1 squared times x plus 2 plus x minus 1 squared times x minus 2 equal 12. Let's see if we can do factoring method for this or not. And if not, If it's not, then we have to do something else, huh? Look at that. So you see that we have x plus 1 square, we have x plus 2, we have x minus 1 square, we have x minus 2. In order to apply the zero product property, everything must be equal 0. Okay, so you have to change 12 over here to the left side and set equal 0 on the right hand side. However, if you look at this, there's nothing in common. There's nothing in common. Okay, so what we're gonna do? Alright, so what we're gonna do with this? One of the other way to solve example number 4, one of the method, the second method I want to introduce you is naming variable method. Okay, what do you mean by naming variable method? I mean, in most of the polynomial equation, variable in terms of x, right? Variable is always in terms of x. Okay, when you name variable, it means that you let some part of the equation equal another variable, and that variable, that new variable, you can have anything. It could be z, could be w, could be t, whatever. It could be s, anything you want, but this could be a different variable from the original one. Okay, before we can start example number 4, I want you to start a very easy problem with naming variable. For example, over here, example 1, x to the 4 minus 6x squared plus 8 equals 0. This is the 4th degree. Okay, as some of you are really good at this, really good at factoring, and some of you look at this and some of you can do factoring method. Okay, but there's another way to solve this polynomial. It is to use another variable. Okay, so if you look at it, if you notice x to the 4 over here, x squared, and x to the 4 is x squared, kind of related to each other, right? Because x to the 4 is nothing but x squared, then you square one more time. Alright, so I can write x to the 4 as x squared and square. Okay, I can write it like that. Now, because I have x squared square, and on the second term I have 6x squared, if I name another variable, I let u equal x squared. So this step is called naming new variable. So I call some part of the equation equal another letter, another variable, in this case letter u, variable u. So if I replace x squared with u, our equation become u squared, right, minus 6u plus 8. Okay, so what we have? Originally we have the 4th degree polynomial equation. Now after naming another variable, we have a 2nd degree, and with 2nd degree we can do factoring. 4u minus 2 equals 0, and we can apply zero product property, and I can solve for you, right? But solving for u is not enough, because we want to solve for x. So u is this, so I'm gonna plug u back into this. So we have x squared equal u, which is equal 4, then x equal plus minus 2. Okay, you plug it in, so you have x squared equal 2, then x equal plus minus square root of 2. So totally we have 1, 2, 3, 4 real solutions. Okay, maybe in college algebra you see this type of equation, the fourth degree already. Okay. However, maybe your instructor, your professor show you how to factor. I mean, if you're good at factoring this, I mean, I don't mind at all. I mean, as long as you get a solution. But I mean, you can go through another method called naming variable by doing this. Okay, because naming variable method is just, it works for many other complicated equations. It's not just simple like this. Okay, for example, in example number 4, we here I kind of introduced, but I never saw it, right? Maybe we have to use naming variable method for this, because look at this. No way we can factor anything here, right? No way we can do that. Okay, but let's see we can solve this with naming variable method or not, or maybe I have to go through another example before we start example number 4 here. Okay. So I'm gonna put over here maybe naming variable method. Okay, maybe I have to use it. Okay, so I put a question mark over there, but we don't want to start it yet. Let's go through another example. So example number 2. Example number 2. Okay. I think I'm gonna use another white paper. Alright. So example number 2. Alright. Let's see if we can solve this or not. So x squared plus x minus 2, x squared plus x minus 3 equal 12. Well, you look at the equation, you must be able to recognize this polynomial equation or not? Well, yes. Yes. Because look at that, if you fold it, if you start folding and it give you the 4th degree, you subtract both sides by 12 and it's equal to 0, it must be polynomial equation. But how are we going to do this? How are we going to solve for x? Of course, this is a pre-calculus, you know, it's not going to be the same level as you do polynomial equation in college algebra. For college algebra, I might give you something, I will give you something easy like this. You know, everybody know how to do this, the college algebra student know how to do this, but in pre-calculus we have to do something else. Okay, so how are we going to solve it? Either a factoring, I mean, factoring method is just a part of, it's also the part of a naming variable. Because naming variable method is like to simplify the hard problem to the easy problem so that you can apply zero product property. Okay, but let's see. Okay. It's very interesting right here. Look at that. If you look at the problem, you have x squared plus x and x squared plus x, right? The first two factors, they have the same term, x squared plus x. I mean, maybe you can name variable for the whole thing there. Maybe, you know, or maybe you can do something else. Let's try to name variable for the whole thing there. Because when you name variable for that thing, our equation it makes simpler. I don't know it's working or not. We work together. Okay, so let u equal x squared plus x. Then our equation become what? Become u minus 2, u minus 3 equal 12. I subtract both sides by 12, so I have u minus 2 times u minus 3 minus 12 equals 0. I fold it, so u squared minus 3u minus 2u plus 6 minus 12 equals 0. I simplified it, minus 6 minus 5u minus 6 equals 0. Look at that. After I name variable, find a very hard, complicated problem to a quadratic. Oh my god. Alright, and what is this? This is quadratic, right? We can factor easily. So we have u minus 3, u minus 2. Can we? This is minus, this is minus 5. Oh, look like doesn't work, huh? Let me see I calculate anything wrong over here. Minus 2u minus 6 minus 5u plus 6 minus 5 is negative 6. Okay, so look like that we cannot factor this, right? Because look at that, we have minus 6 over here. No way we can factor this. No way we can factor this. So the only way we can solve for u over here is using quadratic formula. Oh, we can. I think we can, right? It looks like we can. So you look like u minus u plus 6 times u minus. Oh no, u minus 6 times u plus 1 equals 0. Yes, we can. We can factor. I'm sorry. Okay. But we cannot factor like this, but we can use another pair factor of 6, which is 6 and 1. Okay, so in this case, you can split them up. So minus equals 0 or u plus 1 equals 0. Then you have u equals 6 or u equal negative 1. But again, we haven't done it yet because we need to solve for x, alright? So u equal to 6, you plug it in here, so you have x squared plus x equals 6 and x squared plus x equal negative 1. Right? And now what? We 0, square plus x plus 1 equal to 0. X squared plus x plus 1, if you apply the quadratic formula, so you have x equal to minus plus minus I square root of 3 over 2. So you have 2 solution already, 2 unreal solution, and look like this one we can factor, right? We have x plus 3 times x minus 2 equal to 0. So we have x equal negative 3 or x equal 2. So totally we have 1, 2, 3, 4, and that's it. Alright. So you see that? You see that with name and variable method we can simplify the problem. Yeah, make it easier for you to use factoring method. I mean, so I can say the factoring method is kind of the baby version of a naming variable method. Okay, a naming variable method is like a process. Okay, a process you have to do before you do factoring method. Okay. All right. Now get back to the equation before, the one we thought that maybe we have to use factoring method. Let's see if we can solve this together. Right? So you have x plus 1 squared, the one right here. Okay, x plus 1 squared, x plus 2 plus x minus 1 squared, x minus 2 equal 12. How are we going to solve it? I mean, I'm not going to be stupid, you know, multiply, distribute everything, you know, it's gonna be very crazy. So we're not going to do like that. Not going to do like that. Let's see. Let's see. So we have to think a little bit, and we have to see like, what is the purpose of this. So I think I'm gonna switch 12 to the left hand side. Okay, so we try to find a relation between all the factors right here. I I see something kind of similar. You see here plus, it kind of number kind of the same, right? But the only difference is the plus, and the second part is minus and minus. Over here plus and plus. So let's see what we're gonna do. Interesting. Let's see. How about this? If I foil them, maybe I foil them. I think foiling, I mean, I thought it's stupid doing the foiling part over here, but I think if I foil them, I think it might do something. We're not sure, okay? We're not really sure, but we just try. But look like it might give you something. So let's see. So or maybe we just how about this? X plus 1 square. So here x plus 2 over here, I can split them x plus 1 plus 1, right? And over here I have x minus 1 square. Over here x minus 2, I have minus 1 minus 1 minus 12 equals 0. Okay. So we're gonna have what? We're gonna have x plus 1. I folded x plus 1 to the third power plus x plus 1 squared. Then over here we have x minus 1 to the third power minus x minus 1 squared minus 12 equals 0. Jeez. You think it's working? Okay. Oh, probably it's not working this way. I mean, you look at the equation and you sometimes you have to check, like one method is always easier than the other one. I mean this one will lead you to the answer also. We really hard working on. We work really hard on that, but we have to see if it's anything else we can do over here. Because look at that. So you have 12. If I distribute, so this, I mean, this method look like we I don't know, we might get something else. But let's see, we have we switch strategy. Okay, we can do something else. Let's see what happened. What if we foil it up? So you have x plus 1 square. Let me switch to another way. So let's see it work or not. Okay, we have fun. We have fun. No stress over here. If it's not working this way, we jump to another way. That's fine. Okay. So you have for them. So I have, first of all, I expand this to x plus 1, x plus 2. Over here, x squared minus 2, x minus 1 plus 1, x minus 2 minus 12 equals 0. So you have x to the third. Now I for them plus 2x squared. Plus 2x squared plus 2x squared plus 4x plus x plus 2. Alright, and over here we have x to the third minus 2x squared. Look like we can simplify, right? Minus 2x squared again plus 4x plus x minus 2. Okay, minus 12 equal to 0. So x squared plus x to the third plus x to the third is 2x to the third. 2x squared here. 2x squared plus 2x squared, 4x squared. 4x squared, 4x squared cancel out, right? Oh, I think it's easier this way, huh? For sometimes it happens you. So you have 4x is 8x. 4x and plus x over here is 5x. 5x is 10x. Okay, 10x plus minus 12 gone, right? Okay, minus 12 equals 0. Here you go. Look like this is better. Look like this is better. We thought that it look like it's working, right? So I factor number 2 have x squared x to the third plus 5x minus 6 equals 0. Alright, so our goal is to solve x to the third plus 5x minus 6 equals 0. Nothing wrong over here. 5x, 10x minus 12. Look good. So we have the third degree, unfold third degree. How are we gonna solve this? How am I gonna solve the third degree 5x minus 6 here? I mean, we kind of simplify the problem, but the thing is that you see that we getting stuck with the third degree. You see, sometimes it's the following part, it helps you to simplify that, but we're getting stuck with the third degree. Alright, easy, don't worry. Alright, you see that if you look at the problem, you see if you plug 1 into the equation, right? If you plug 1 into the equation, we have like 1 to the third plus 5 times 1 is 6, 6 minus 6. So 1 is the 0, and if 1 is the 0, remember we can do synthetic division. So 1 is the 0, I do synthetic division here, so I have 1 0 5 negative 6, right? So I do synthetic with 1 1 1 1 1 here, 1 over here, add up 6, negative 6 over here, 6 over here, add up 0. Here you go. See that? You do divide by 1, the remainder 0. It means 1 is the 0. Okay. So what we have, our quotient will be x squared plus x plus 6 equal to 0, and this quadratic over here. So we can factor. We go 1 is 0 already, so we have x minus 1 times x squared plus x plus 6 equals 0. I split out x minus 1 equals 0, x equals 1, x squared plus x plus 6 equal to 0. So this is quadratic, so x equal to plus minus s minus b minus 1 plus minus b squared was minus 4ac. So over to here you go. You get another two solution here. So we have negative 1 plus minus minus square root of 23 over 2, right? Which is negative 1 plus minus I square root of 23 over 2. Here you go. So you have totally 2 x to the 4. You have 2 unreal and 1 real, and that satisfy the number, satisfy fundamental theorem of algebra. So look like that this problem, you see that we don't have to do naming variable. We can avoid them, and we start doing syntactic division. It works. But I do believe that naming variable works. Okay, so we got it. Okay, we got a solution for this equation. Okay, but I still believe myself that naming variable work. So let's try to figure out how we're gonna name variable here. How we're gonna do that? Let me work on the side. Okay. So I try to do a second way for you, because I try naming variable for this problem. let me redo the problem here with another way. Okay. Think. I see the relation. I do see it. Okay. How about this? So I have x plus 1 square, x plus 2 plus x plus 1 minus 2, or maybe x minus, hold on, this x minus 1 square, and over here x plus minus 1 minus x plus 1 minus 3. Let's see it work or not. No, it doesn't work. No. How? Interesting problem, right? Try to figure out another way for you. It should work. It must work, because I put over here. It means that we can solve for that. We can solve for that easily. Or maybe I'm split it up like this. So x minus 1 plus 2 plus x minus 1 square, x minus 2 here. Then I forward it, so x minus 1 square. I split it up. And I give you x minus 1 square. I mean, yeah, this is more complicated. So I think I'm gonna stick to the following part, you know, because this is another trick way to name in variable for this problem. So let me continue with another one, because we don't want to waste too much time on this. But I'll think about this. I'm going to try to name variable for this. Okay, I'm trying to do that for you. Okay, maybe later. All right, let's continue with the. Let's see if we have any other example. Yes, we do here. Oh, how about this one? This is interesting also. I don't know if we can work on this or not. All right. How about this? I have 2x plus 1 term x plus 1 square, 2x plus 3 equal 18. It's polynomial, but it's not in factorial. It's in factorial on the left, but on the right hand side we have 18. Okay. So what do we do here? Okay, look at this, look at that, look. How about this? I have 2x plus 1. Oh, this one is not really that bad right here. So I split up, so it will be 2x plus 1 plus 2, right? Alright. And okay. So if I start foiling, look at that. No, 2x plus 1, x plus 1 square, right? So then I factor x plus 1 over here plus 1, right? I factor number 2 out. Okay. So we just have x plus 1. Okay. If I factor let u equal x plus 1, then what happened? Let u equal to x plus 1. then we have what? So x equal to u minus 1, right? So we're gonna have 2x equal to u minus 1 plus 1 times u square times 2u plus 1 equal 18. Do you think it make it simpler? So we have it's not gonna be simpler. It's kind of, so we have 2u here plus 1 u plus 1 equal 18. So 2u minus 1 right here. There you go. Right. So u square 2u plus 1 u square, so x equal to x plus 1. So let's just check one more time. X equal to u minus 1, u minus 2u, negative 2 plus 1, negative 1. So you have u square, then you have 2u minus 1 times 2u plus 1 is the 2u square minus 1, right? Equal 18. Right? You got a minus b times a plus b. Okay, so I have 4 of them, so they become 4u to the 4, right? Minus u square minus 18 equal to 0. And what is this? Yeah, this is I can name another variable. I can name another variable here, right? So I can let t equal u square, then it becomes 4t square minus t minus 18 equal to 0. Okay, right? Alright. Then from here, what we're gonna do? We're gonna do quadratic. Is this quadratic, right? Let's see if we can factor this or not. So for let me see. I can factor this. Let's see. So look like we can factor. Yes, we can factor this. So we can factor this. I'm not going to go through the factoring part here, because in this course, everybody knows how to factor this. So just take time to factor. So you have 4 here, t. I factor this 9 over 4 and t plus 2 equals 0. So you factor is going to be 4t minus 9 t plus 2. Right? 4t minus 9 t plus 2. Right? 4t 8t minus 9. Yes. Alright, so you have what? We have a t, 4t minus 9 equals 0, or t equal negative 2. Alright. So over here we can have t equal 9 over 4. And over here we have t equal negative 2. Actually back in the day when you in college algebra, because when you let t equal to u square, when t is negative, you're gonna just go ahead and throw it away. But because I want you to suffer everything, so it still works, because we get the imaginary one. Okay, so you're gonna have u square equal to negative 9 over 4. So u will be equal to plus minus 3 over 2. Okay. Okay, over here we have u square equal negative 2, so u will be equal to plus minus i square root of 2. Okay, now I'm going to solve for x, because after you got you plug over here, so your x will be plus minus 3 over 2 minus 1, and x over here will be plus minus i square root of 2 minus 1, so which is x equal to 1 over 2 or negative 5 over 2, right? And over here your x will be equal to i I square root of 2 minus I, or negative I square root of 2 minus I. So totally we will have 2 real and 2 unreal. So you see totally we have, you see that highest power will be 2 degree, 4 degree, 2 degree, 3rd degree, and a 4th degree. So 1, 2, 3, 4. All right, it's satisfied. So you see in this problem, you see we have to name variable twice. We have to name variable twice. Okay, I mean, if you look at some of students really good at it, and they really simplify the problem, you know, in a better way. You know, I don't mind. I mean, as long you don't have to follow, because math is very flexible. It's, you know, you gotta be flexible. You know, it's this the strategy is just have you to see the first few steps, but you have to be flexible and try to figure it out yourself, as long as it's logical. Okay. So this problem, you have to name variable twice, and you see that it takes a lot of time. Let me see. I look at the problem again, and I see is there any other way. Maybe some of you just go ahead and forward. It worked last time, but let's see, is there any other way? Okay. All right. That's very interesting. We can name another way. We can name variable in a different way also, but it probably take you the same amount of time. You know. So I think I'm gonna just stick to. I think I will stick to this method for the time being. I mean, I can let u equal to 2x plus 1. It probably work. It probably work. Yeah. So this 18. It might work if you let u equal to 2x plus 1. Okay. All right. So that's all the example I can give you for 7 polynomial equation. On the second part of this lecture, we're gonna just focus on 7 polynomial inequality. I think in college algebra you learn how to solve the very basic polynomial inequality already. Inequality means greater than, less than, blah blah blah. And the most basic one you learn the quadratic inequality. Okay, the second degree one. Okay, so I'm on this lecture, let me go through the first example with the basic one, quadratic polynomial. Then we're gonna keep moving up to the harder one. Okay, second part. Polynomial inequality.